Hi, in this video I'm going to show you how you answer question 8 on the THS practice paper 1 for A-level core 1. This paper has been made for AQA but is suitable for the exam boards. As ever, get in touch with me if you want anything on Twitter at Mr_G_Walton or our school account at Tupton Maths. If you haven't got a copy of the paper and you would like to download it, look on the link below on YouTube and you'll be able to download the paper from there. So question 8 says the volume V meters cubed in a tank at time t seconds is given by this. A third t to the 6 minus 2t to the 4 plus 3t squared for when t is greater than or equal to 0. So this last bit is just telling us that time is greater than or equal to 0, so we're not dealing with something in the past. Okay, or negative time, which we can't have. Part A says, find the rate of change of the volume of the water in meters cubed per second when t equals 2. Okay, so the key part of this is rate of change. Now we've done work on rate of change in the past. You'll have done it in class and you will have done it in terms of how one thing changes compared to something else. And the thing that you probably have done is how y changes in comparison to x, or the gradient function. Now, this is exactly the same. We are going to look at how one thing changes compared to something else. In fact, what we're actually going to look at is how v changes compared to t, or dv by dt. So this is a differentiation question. It doesn't say on there that it is, but I'm hoping that by now I've said the rate of change, how one thing changes, how v changes with respect to time, how v changes compared to time, over time. Okay, so we're going to do dv by dt. We're going to do exactly the same thing as we would if we were doing dy by dx. And all these things here were x's. If it said y equals, we'd do exactly the same thing. So let's differentiate it. dv by dt. Remembering that differentiation, you multiply by the power and reduce the power by 1. So here we've got 6 over 3, which is 2t to the 5. Minus 8t cubed plus 6t. And it says find the rate of change of the volume when t is 2. Okay, so I've found the rate of change of volume, dv by dt, or at least a function that shows the rate of change of volume. What I now need to do is substitute 2 into here. So I've got 2 lots of 2 to the 5 minus 8 lots of 2 cubed plus 6 lots of 2. 2 to the 5 is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2 again, which is 32. So 2 lots of 32 minus 8 lots of 2 cubed, which is 8, plus 12. So I've got 64 minus 64 plus 12, which is 12. Now it says in meters cubed per second, so the rate of change is 12 meters cubed per second. Okay, so part A is done. 5 marks for this, but that's mainly because it's interpreting the question. It doesn't tell you anywhere, find dv by dt, hence work out such and such. You just expected to remember that this is what we're doing. Okay, so the key word, rate of change. Okay, let's look at part V then. So part B says verify that V has a stationary value at t equals 1 and determine whether this is a maximum or minimum value. So let's just get back up what our function was telling us, our rate of change function. So dv by dt was 2t to the 5 minus 8t cubed plus 6t. Okay, so it says verify it has a stationary value. Well, a stationary value occurs, in this case, when dv by dt equals 0. So this is when we get a stationary value. So I might start off by saying dv by dt equals 0 when stationary. And then if we substitute 1 in, we should get, fingers crossed, 0 coming out. So 2 lots of 1 to the 5 minus 8 lots of 1 cubed plus 6 lots of 1 gives me 2 minus 8 plus 6, which does in fact equal 0. So we can say, therefore, t equals 1 gives a stationary value. Now the next part, it says, and determine whether it's a maximum or minimum value. Okay, so in order to do this then, we're going to have to find the second derivative. So we're going to do the second derivative test. So we are now going to differentiate our derivative. So we're going to get d2v over dt squared is going to give us 10t to the 4 minus 24t squared plus 6. We're saying at the point when t equals 1, so we have to substitute 1 into this, we get 10 lots of 1 to the 4 minus 24 lots of 1 squared plus 6, which is going to be 10 minus 24 plus 6, which is a negative value. So I've got minus 14, minus 8. This gives me minus 8, which is negative. And we're remembering that when we have this kind of problem, I'm just going to budge this up just a little bit so we can see. When we have this type of problem, we can say that if d2y by dx squared, if you remember from before, if that was less than 0, then we had a maximum point. We're going to use the same principle here, and we're just going to say that d2v by dt squared is less than 0, therefore this is a maximum. Okay, that's that part done too. Now this particular question didn't tell us anywhere it was going to be a differentiation question. The clue was all in the wording, and it talked about a rate of change, and that's what differentiation is. I apologise for the spelling mistake here. Differentiation is not spelled like that, but it is about rates of change. The question might not ask you to find dy by dx. It could be two different things. In our case, we had the change in volume as time changes, so dv by dt. When we're doing this type of question, it says substitute the given value into the derivative function to find the rate of change at that point. That's no different to finding the gradient at a particular point using your gradient function. And determining max or min requires the second derivative test. So if it's greater than 0, it's a minimum, and less than 0, it's a maximum on these types of questions. If it did equal 0, then it would be a point of inflection. So point of inflection. And if we were drawing a graph for that, you might think of something like a cubic, for example, where we've got a turning point here. It's neither a maximum or a minimum, it's just a point where the graph turns, and that's called a point of inflection, just for completeness, really. Okay, hopefully this has been useful, and good luck with any tests. If you need anything, get in touch, and I will see you soon. Bye.